hard knock life for us. It's a hard knock life for us.
2, 3.
So yeah, we came up with this idea from the internet and also some of my personal experience from forensics in Science Olympia. And that's how we came up with the idea. Our idea is we're going to do the flame tests on different chemicals and see which one works best as a flare. Okay, the control variables in this lab would be the amount of solution, the amount of moles for each substance of the flame. Wait, what? I'll edit this out. The brightness of the room and the same equipment. And lastly, the experiment variables was the compound that we tested.
Okay, so basically the way our experiment works is we make the solution out of the compound and then we burn it in the flame. Yeah. And for the background info that relates to this experiment, it's the structure of an atom, the electrons and the energy levels, and light and photons. And important equations are the combustion of sucrose, and all the dissociation equations for all the different chemical compounds we used, like the dissociation of potassium chloride, strontium nitrate, all that good stuff.
Hydrogen and oxygen and nitrogen and uranium and nickel, neodymium, neptunium, germanium and iron, americium, ruthenium, uranium, europium, zirconium, lutetium, vanadium, and anthium and all.
So the way we're going to set up this experiment is we're going to set up a Bunsen burner and make the solutions. Our hypothesis is a copper chloride will burn the longest, and since it's going to burn green, green is highly visible, and the longer duration is the higher chance someone can see you and rescue you from your situation. And we will measure results by the duration of the flame and quantitatively gauging the brightness of the flame.
Okay, so we're burning the strontium nitrate, and it's our control. And as you can see, it's burning a pretty bright red. So for this reaction, what we did was we mixed 1.225 grams of potassium chlorate, which is 0.01 moles, and then we added excess sucrose, and from there we added 10 milliliters of water. And we burn this reaction, and it produces a highly exothermic reaction that is reddish in color, and what's basically happening is you have the sucrose being oxidized by the oxygen produced from the decomposition of potassium chlorate.
So for this magnesium sulfate, we tried using 0.01 moles of it, and then when we burned it, there's nothing that showed up. So yeah. So yeah, there's nothing.
So lead acetate was next. We put 3.25 grams. It burned to be a pale lavender, and it burned really quick. So yeah, that was it.
Here we're burning 2.8405 grams of ferrous ammonium sulfate. It's giving off a few sparks, but other than that it doesn't burn well, so it's basically useless if you're lost.
So for the zinc chloride, when I looked at it at first, I was like, hey look, Joy, look at this, it's so old. And she's like, oh yeah, just burn it anyway. So I was like, okay, fine. Like, you know what, fine. So I went back, I started back again. And so, but seriously, we got 1.636 grams of zinc chloride, mixed it with water, and as you can see, it burned orangish, yellow, with some smoke in the end.
So next was magnesium chloride. As you can see, I follow lab procedure by cleaning the nichrome wire with distilled water. And we put 0.952 grams of magnesium chloride with 10 milliliters of distilled water. It turned out to be an orange color.
So for the potassium chloride, as you can see, Michael is very well at doing this. He used a nichrome wire to specifically measure out 0.74 grams of potassium chloride. And then when you burn it, as you can see, it has a very purplish color. Ignore the orange, that's just something else. But yeah, We recommend using this for a campfire to have cool colors rather than having it as a flare because this is not very bright or last long.
So we did iron 2 sulfate. We put 1.59 grams, and all I had was sparks. This is very ineffective as a flare.
In this trial, we dissolved 1.25844 grams of manganese chloride in 10 milliliters of water, and as we burn it, you can see that it's burning sort of a blue and a purple and a green, and it also gives off some sparks. We think part of this may have been because we kind of, goofed and there was contamination, but, whatever.
So for this one, which is, as you can see, copper 2 chloride, as the title says, this one emitted like a very greenish color and tiny bluish, as you can see on the side. When we did this, we took out 1.345 grams of it, and then, yeah, there's just my hand. Whoops, I accidentally burned myself. Ignore me. Yeah, no. Okay, look away. Okay. So then we're just like, oh, let's relight this stuff. There we go. Okay. Yeah, then we burn it again. As you can see, more green. So yeah. So yeah, why would I say oh yeah so much? We did research and then we figured out that the green was the most visible light of all the other colors. So if you're stranded, green is the best light you can do to show people that you're there.
And we speed this up.
You calling? Oh, he's like
Let's get down to business to defeat the Huns.
This experiment was that we Michaeled stuff up, and basically what Michaeled stuff up means is that when he was trying to light the Bunsen burner, he lit it and it was successful, and then he turned it off. So that's what that means. And then we also had outdated chemicals like zinc chloride that was bought in like 1992. Stuff also went wrong because stuff just went wrong. I don't know what to say right there. Used it and lived with it.
Even though we have problems, man, we just gotta solve them through,
Girl on part there, Jackie.
Oh, we had a very short
a
Bunsen
ratchet
burner.
Bunsen burner, yeah.
Yeah, that's it.
And so for our results, what we did was we measured the duration of the flame that the solution produced, and then we also looked at the intensity of the flame. And so what we came to for a conclusion was that copper chloride burned the longest, and it was also had a pretty vibrant flame, so we thought that was the best.
My hypothesis was right.
Michael.
The summary of this experiment, well, lab. Sometimes you try your best, but you don't succeed, so you gotta burn it again. With multiple trials, science can get repetitive and boring. It's a hard knock life.
54-year-old Ron Tubbs was following the stars last night, and tonight he's counting his lucky stars. He was rescued at sea after a harrowing 8 hours floating away from Oahu's west shore. Kirk Matthews has this great story of his survival and rescue. Kirk.
Marissa, Ron Tubbs and his partner began their usual day looking for aquarium fish off the Waianae boat harbor. The ocean had other plans. Ron Tubbs and his partner Scott Folsom call their boat the Yellow Beast. But while they were diving yesterday, at some point, Tubbs was unable to get back to the boat.
I
Tubbs was carrying a green laser, smaller than a flashlight, to let the Coast Guard know where he was.
I was hanging on to that green laser pretty tight because I didn't want to lose that because that was my last chance. And that pretty much saved me right there.